Here's an interesting fact. If you take any two sinusoids of the same frequency and add them together, their sum is a sinusoid too. They can have different amplitudes and different phases, but as long as their frequencies are identical, then they'll always add together into another perfect sinusoid. Isn't that weird? I mean, look at these curves. Maybe you would guess that their sum is periodic, like they are. Maybe it looks something like this, or maybe this. But no, turns out their sum is exactly, precisely a sinusoid. Every time. This really surprised me when I first learned it, but it's true. Here's a proof. Did you catch that? Yeah, me neither, but it doesn't matter because it turns out there's a much, much simpler approach to proving this. Imagine a vector rotating in a number plane, like this. As it rotates, notice the way its two orthogonal components grow and shrink. Since they're symmetrical anyway, we'll declutter things by focusing on the y component. Now, as you may know, the y component of a vector is proportional to the sine of the vector's angle. So this y component as a function of time can represent any generic sinusoid. In fact, in my opinion, that's the best way to define what a sinusoid is. It's a one-dimensional component of circular motion in 2 dimensions. Now, let's add a second vector with the same frequency. Its length is different, and it's at a different point in its rotation, but its period is the same as that of the first vector. As a consequence, the angle between the vectors never changes. Each one sees the other as still relative to itself. Now, you can probably see where this is going. We'll add the vectors together, and move the y components to the center, just for aesthetics. And look at that. Because of the fixed angle, the sum of these vectors traces out a perfectly circular path. And the y component of a circular path must be a sinusoid. Therefore, the sum of any two equal frequency sinusoids must be another sinusoid of that same frequency. With just a slight paradigm shift, this fact goes from totally surprising to trivially obvious. This equivalence between sinusoids and vectors in a number plane turns out to be super useful, and thinking about sinusoids in this way can shed light on all kinds of problems that would otherwise be really difficult to solve. But I'll leave exploring some of those up to you. The larger takeaway here I guess I'll leave that up to you too.